Today, I will explain the differences between symbolic links, hard links, and file copying in the Linux file system. Understanding these concepts can help us better manage files and disk space. Let's start with the simplest one, file copying. First, let's check the current directory, where we find a file named file.txt. Using the cat command, we check its content and see that it contains a string of characters. Now, let's copy the file.txt file and create a new file named copy.txt. After checking the file information in the directory, we find that there is no difference between the two files. Printing the content of the copy.txt file, we see that it is the same as file.txt. Let's modify the content of the file.txt file by adding a few characters, and when we print it again, we see the changes. However, printing the copy.txt file shows that its content has not been modified. This is because copying duplicates the original file content into a new space on the hard drive. While the contents of the two files are identical, they are not otherwise related. Let's also print the inode numbers of the files in the directory, and we'll find that the inode numbers are different, meaning the two files belong to separate memory spaces. It's like creating a new storage space that contains exactly the same content as the original. Next, let's explain what a hard link is. We'll use the ln command to create a hard link to file.txt called hard.txt. When we check the inode number of hard.txt, we find that it is the same as file.txt. We then print the content of the hard.txt file and find that it is the same as the content of file.txt. Let's try modifying the content of file.txt and then come back to check the content of hard.txt. We find that the content of hard.txt has changed as well. This is because hard.txt and file.txt share the same storage space, and the hard link essentially creates a second access point to the original file's content. It's like adding another door to the same storage space, so the hard link doesn't use any extra disk space and only uses a small amount of space in the file name metadata. Next, let's use the ln command to create a symbolic link for file.txt, naming it soft.txt. Using the ls command, we can see that the symbolic link looks different from regular files. When we print its content, we find that it matches file.txt, but when we check its inode number, we see that it is different from the original file, meaning the symbolic link occupies a different memory space. So, how does a symbolic link work? We'll try deleting the file.txt file, and when we print the content of soft.txt, we find that it can no longer access the directory. Now, let's create a new file.txt file and write different content into it. When we print the content of soft.txt again, we see that it has changed to the new content. This shows that a symbolic link is just a directory reference tool. It doesn't point to the content but to the file's path. Its function is similar to a shortcut in Windows. Using the storage example, it's like receiving a note telling you where the storage is located. We can summarize the differences between these three methods mainly in terms of how they use disk space. Copying a file creates a new space with the same content, a hard link adds another access point to the content, and a symbolic link provides the address to access the content. That's how I understand the differences between the three. Thanks for watching.